So as I understood, I think you are asking if the optical properties of oil, when it changes, it's going to affect our simulation. So this simulation is based on like the physical properties. It's just based on the effect of wind and surface currents. And we didn't consider a lot of like properties that can change in the oil, like the chemical properties of the oil, weathering processes that are happening. We exclude those properties, and it just has the physics, which are moving the oil on the surface.
But does that affect the SAR detection of the oil?
Oh, SAR detection of the oil. Actually, you want to know if during the time SAR images are going to change because the properties of the oil changes. So SAR is not an optic image. It works based on radar sensing. So what we see is only the dark target. So during the time, the thickness of the oil can change in the SAR images. So we are able to see the oil, which is like about 1 micron or more than 0.1 micron, but less than that, we are not able to detect the oil. So we are actually not looking at the change of the oil in the SAR images during the time. We only look at that moment that SAR was taken. Yes, during the time, the properties of the oil changes. So what we see in the SAR, it's going to be different. But we are just looking at that moment and the age of the oil at the moment that the SAR satellite image was taken. So if we want to study the time period and like SAR images in a specific time period, yes, it changes and it's going to affect our results. But we didn't have that type of data set because, we dig the archive and we only found 41 images from 2003 to 2011. But if we have that type of data that like covers the whole period, it's going to be really helpful because, we can see the reality, what's going on in these SAR images. Unfortunately, we don't.
Thank you. Have any other questions? Yes.
This question is for Hoskins. Okay. What kind of data mining software has been used?
The question is what kind of data mining software has been used. And typically what we'll do is because we work for our customers, we will stream that data to wherever they want it and they'll manage the data. So typically we don't worry about that. We just go collect the data and then get that back to a central location for processing and input into a common operating picture.
Ms. Adam, you mentioned the term marine snow in your presentation. It's the first time I'm familiar with it, but would that include bacterium?
So the question was if marine snow, which I mentioned in the presentation, would include bacteria. So marine snow, it's often in these aggregate forms, and so it's decaying material that's sinking through. So it's often colonized by bacteria that are breaking it down. So yes, it's not. I guess it's this kind of catch-all phrase, but in reality, it's dead diatoms. There's bacteria on it. There are also zooplankton that sometimes feed on the marine snow that are attached to it. We actually have some images I didn't show today, but where the zooplankton are actually feeding on the marine snow itself. And so it's really just an aggregate, yeah. But bacteria is definitely a big part of what's going on with those aggregates.
Adam, how do you foresee your technology being used in future oil spills?
The question was how I foresee imaging or plankton imaging technology being used in future oil spills. So as far as something that you would use on the ground as part of a response plan or mapping the distribution in real time, it's possible that you could use it to get a quick survey of, say, the particle sizes and abundances in the we around an oil spill or something like that. But I think the main value of it, especially with regards to GOMRI-funded research, is that we really didn't have much information about all these different groups and how they're distributed at the time of the oil spill. And so now that we've had a lot of research in this area, we have a much better understanding of the seasonality of different groups, and like I kind of mentioned in the presentation, just knowledge of that information can allow us to model or understand some of the biological impacts that before we wouldn't really have any clue about what was happening. But you need a ship to deploy it. Ship time is expensive. So I do envision and a lot of the drone technology and things where we can get out in the ocean and sample in a cheaper way. I think this kind of technology could be adapted to, say, a mooring or something where you can put it out there and it can be sampling more regularly, as opposed to a lot of the data I work with where we get a really detailed picture of what's going on in one area, but we don't know what's happening all around us. And so I think that's kind of the key thing that's missing with regards to the imaging technology and its application.
Thank you.
Yes.
There's a question for Mr. Hoskins. You indicated that your maximum height on your aerostat was 500 feet. I was just wondering if that was an optimum for detection of the oil. And the second question is, how many balloons have you lost?
Let's see if I wrote the question. First, how many balloons have I lost? None. That's an easy one to answer. Thank goodness. And then the optimal height for detection. Well, typically we'll fly at right around 450 feet, because the higher the height of eye, the further our reach, right? The further we can see. And we can usually detect at that height about 4 miles. We'll detect oil. But to really classify actionable versus sheen, we're really talking maybe 3,000, 4,000 feet. And again, it's all scenario specific, how much humidity, what are the environmental conditions. So detection is a little bit further out, classification typically 3,000 to 4,000 feet. So, that answer your question?
So you're going up pretty high, several thousand feet with your aerostat, is that correct?
No, 500 feet. But 500 feet, I'm looking out at 3 or 4 miles and detecting oil, right, at 500 feet. But really being able to define what is actionable, now we're talking it's a little closer, like 3,000 feet, away from the vessel, away from the balloon.
Okay.
But not altitude. We're capped at 500 feet by regulation.
Yes.
Dr. Samir, you mentioned 900 plus natural seepages in the Gulf of Mexico.
Yes.
Did you do any research or know what that quantifies to as far as annual volume seepage?
You are actually asking about 914 seep zones in the Gulf of Mexico, and you want to know about the annual volume of these oil slicks. So actually I put the reference, McDonald et al. This is actually the work that Dr. McDonald did with Oscar. I don't know about the annual, but I know that the way that they figured out the number of these seep sites was based on the surveys that they did with SAR images covering the whole Gulf of Mexico. They had a complete archive, and they checked these images and the overlaps they had to see if these seep sites are active or not. And they gave this estimate of these are the active seep sites that if you check SAR images, you are able to see the oil slips on the surface of the water. So, but I don't have that on top of my head to give you an estimate. But if you check the paper, you are going to be able to see better numbers of the volume.
Sorry, I have a follow-up on that question. So the seeps are down at the floor. Obviously, they have to come through the water up to the surface. So how do you basically correct the images for currents and things to actually know where the seep is physically located at the bottom of the seafloor?
Yeah. So when you check, for example, for the GC, you are asking me when the oil comes to the water surface, it's going to be in the water column, it's going to get affected by the current. So when the oil comes out to the surface, it's not exactly at the side. So when we are checking, and that's why they define these seep zones based on like based on these movements of the oil on the surface of the water, they are not saying that this is like one seep side. They are defining these seep zones. So for the GC600 side, we have like cases that the oil moves like about like 100 meters. It can be away from exactly the site itself, but since there is no other thing around that area to generate oil, we definitely know that this oil is that comes from the GC600, for example. But like, for example, in the case of the Deepwater Horizon, people, when they were studying the satellite images, the case of the Deepwater Horizon, there were several natural seep sites close to the Deepwater Horizon oil. You could see the oil on the surface, and beside that there are some natural seeps on the oil. Even when I was studying myself, like I could see the oil slick from the Taylor Energy platform, former site of Taylor Energy platform, beside this Deepwater Horizon oil. People may get confused and consider that as a part of the Deepwater Horizon oil, but we definitely know that that comes from another site, or the natural seeps which are beside this Deepwater Horizon oil. Since we knew like the location of them, we never like mixed them up with the Deepwater Horizon. And I actually wanted to add something regarding the first question that they asked. For the case of the Deepwater Horizon, we had satellite images that were taken daily, and we had like a complete archive of SAR images, so we were able to track these changes that are happening to the oil. And like the oil disappears, or we have the formation of the oil. But for the case of the natural seeps, since we don't have like daily images, we are not able to study like the change in the shape and color.
I have but I should get the phone because it's long. Let me grab the phone first. It's a two-part involved question, and y'all don't want to have to repeat it. Trust me. Okay, so this question is for Mr. Hoskins. Has MSRC or your service providers been able to overcome some of NMFS's flight restrictions with respect to not being allowed to fly below 1,000 feet when marine mammals are present? If so, did the solution involve an incidental harassment authorization? And when you talk about recoverable versus non-recoverable oil, I'd like to know if it's possible to concentrate sheen in a current buster with diversion boom and then make it become recoverable with skimmers or sorbent pads. Thank you. Wow. And so I can split that up if you want to answer the first one and then have me reread the second one. I can do that too.
Well, I don't know if I'm the right guy to answer the second one, because I'm just not the operational guy out there with the boom and the skimmers. I'm the telecom guy that inherited remote sensing about 4 years ago. So unfortunately, I don't know that I'm the right guy to answer that question, but I can certainly take it back and get you an answer for that one. Now, the other one where we're flying below 1,000 feet, typically we don't want to fly below 1,000 feet. And so to date, that really hasn't been a concern of ours, because optimally we would like to fly at 4,000 to 5,000 feet. And if we're down at that low level, if the cloud ceilings are that low, then we're having to fly below 1,000 feet, we probably won't fly. Now, we would certainly coordinate, all of our flights are coordinated through an air boss, right, who's in charge of the aircraft that are running the spill, and we would coordinate that, and I assume that those types of permissions would be coordinated at that level. So, hopefully that answers your question. And I will get back to you about the ability to push the machine into a buster and collect it. So, all right.
Do you have any more questions? Steve?
Kevin, I appreciate your reference to Oscar a few times as an example of some of the research that's come out after Deepwater Horizon that's now transitioning to application.
Right.
I think that's what everybody would like to see. Do you have a couple other examples or one or two other examples of maybe where you've seen that happen over the last 8 years?
The question for the guys on the phone is there any other technologies that we might see on the horizon that would help us? And the answer is yes. We did a training evolution with a company, David Chenault, does anybody know David, with Polaris sensors. And he has, let me make sure I say this correctly, a polarized IR camera that is much more sensitive to sheen, where typical IR cameras will not detect sheen. His camera does, and we just did this evolution in conjunction with a drill off the coast of Louisiana, and we went out to Taylor, and his camera was able to see rainbow sheen, which was kind of unique. Now again, in our application, we want something that will discern the thickest oil, but as far as detection, and that's I think what their thought is with this product is being proactive and being able to detect even a small amount of oil in the water as a the red flag goes up, so we have a problem. So that's a very interesting technology. And there's another company that that we're looking to do some training with. I think it's called Marine Induced Organization or something like that, where they're actually doing detecting hydrocarbons in the water column. They're dragging a cable through the water column and injecting voltages and measuring. They're sending out a current and measuring it, more fluid down the cable, and apparently hydrocarbons impact that sensitivity or footprint that's received. And they can actually put fingerprints on particular types of oil, put them in a library, and then, so yes, the answer is yes, and we're always looking for opportunities to train, to test other technologies that are out there, because there's a lot of cool things that are happening for sure. So,
Our online questioner clarified that in the flight question, he was actually speaking of drones. Could drones, when you sent drones below 1,000 feet, did you have to request the specific?
Typically, we haven't had any issues with
Okay.
drones. I mean, offshore, we've done a few training evolutions offshore with the drones, and then I've done one just we did some mapping along the shoreline in Galveston, Texas, but I don't think there was any concerns as far as that was concerned. So.
Yes.
Good afternoon. For Dr. Samar, if I understand correctly, you said your SAR device, it works off of frequency differentiation between hitting water and oil. Have you all determined that based on that return frequency, if it's oil or some other anomaly or say algae, are you able to say this is oil or this is not oil?
So the question is that is SAR able to detect lookalikes?
Right, based on the frequency return, are you able to determine whether or not, yes, this is oil that we are looking at, or that this is something else, say algae?
So I think, as I know, SAR can get confused. That's one of the problems with SAR images, that it can detect false positives as oil. So it goes back to the experience of the person who is detecting the oil slick at this point, to not to get confused with something that's, for example, sargassum or low wind. Low wind can look like oil slick on the surface of the water. So that goes back to the experience of the person who works with these images. But there is this possibility.